Welcome to another series of EP Ever video tutorials. Today, we will introduce the HP Series 20SA, our most advanced charging inverter. This video will showcase the step-by-step guide on configuring its three-phase operation. Whether you're a professional installer or an enthusiast in renewable energy solutions, this guide will walk you through the process, ensuring a smooth and efficient setup. So let's explore the capabilities of the HP Series 20SA together. The HP Series 20SA is a cutting-edge inverter charger featuring pure sine wave output, compatible with various generator types for charging. It includes an integrated BMS link module and a historical data record function. This device is capable of managing multiple energy sources and supports both single-phase and three-phase parallel output in a fully digitalized format. In the following segment, we'll guide you through the phase setting process for the device and demonstrate how to establish a three-phase connection. Topics covered include: set device phase and battery connection modes, connecting input and output wires, linking parallel communication lines. Our standard configuration allows for the parallel output of up to 12 devices. Customization options are available to increase this number if required. For three-phase parallel operation, a minimum of 3 identical devices is necessary, one for each phase, A, B, C, with a maximum of 12 devices connectable in a three-phase setup, 4 per phase. The method of parallel connection is illustrated in this diagram. We will demonstrate the three-phase setup using 3 devices as a model. These are from the HP AHP0650P20SA series, alternatively known as HP Series 20SA. Each device features a front-mounted LCD screen and 5 control buttons. The communication interface for multi-device parallel connections is situated on the left side of the product, and input and output interfaces located at the bottom. Before initiating the three-phase input and output connection, it's crucial to power up each device individually and set the appropriate phase and battery connection modes. This involves opening the wiring cover of the device, connecting the ground wire, attaching the battery, and turning on the device switch. Connecting the ground wire, attaching the battery, turning on the device switch. Once the device is operational, you can proceed with configuring the phase settings and battery connection method. Phase setting and battery connection are software-based tasks, accomplished using the device's front screen interface. To begin, long press the Enter key to access the administrator interface. Next, press the Enter key 5 times in succession to enter the administrator password, 0000, which will take you to the BMS data interface. Then, press the Enter key twice to navigate to the Set Data Navigation interface. You can complete the phase setting and battery connection method in the second, load, and fifth, basic, options respectively. We'll now demonstrate these steps in detail. Use the down key to select the load option and press Enter to enter the load setup interface. Continue using the down key to reach the phase set option and press Enter to enter the phase set interface. The default setting is single. Since this setup is for three-phase operation and this is the first device, it needs to be set to phase A. Do this by navigating to phase A, using the down key and confirming with Enter. Finally, press ESC to return to the Set Data Navigation interface. To configure the battery input mode, first use the down key to select the basic option, then press Enter to access the basic input mode interface. Continue pressing the down key until you reach the last option, BAT input mode, and press Enter to enter its settings. In this section, you'll find two options for battery input modes. Shared. Independent. The shared option indicates that all devices in the three-phase setup use a single shared battery bank. The independent option means each device in the three-phase arrangement connects to its own battery bank, or each phase is connected to a common battery bank. It's crucial to ensure that the battery input mode setting corresponds with the actual connection method of the battery bank. Incorrect settings can lead to device damage. Considering cost-effectiveness and ease of use, we recommend the shared input mode. Additionally, our demonstration will be based on using the shared input mode. Proceed to set the shared battery input mode by pressing the up key, navigating to shared, and then pressing enter to confirm. Subsequently, press ESC multiple times to exit the settings. After this, turn off the device. Wait for more than 10 seconds before turning the device back on. Repeat the steps you've previously followed to verify the phase setting and battery input mode of the device. Ensure that the phase set is correctly set to phase A, and the BAT input mode is set to shared, indicating successful configuration of both settings. Press ESC to exit and then power off the device, removing the battery. For the remaining two devices, apply the same procedure, setting their phases to phase B and phase C, respectively. Ensure the battery input mode is consistently set to shared across all devices. Power on these devices again for confirmation. Once you've successfully configured the phase and battery input modes for all three devices, you're ready to proceed with the wiring for the three-phase input and output connection. The procedure for wiring the three-phase input and output is as follows, as depicted in this diagram. Protective earth connection. Start by connecting the protective earth wire to each device individually. Battery bank connection. Connect all devices independently to the same battery bank. It's important that the wire gauge and length from the battery bank to each inverter are identical to ensure uniformity. Load connection. First, connect the neutral wire, N phase, of all devices separately to a bus bar, then connect this bus bar to the load. Next, connect the live wire of each device to the corresponding A, B, C phase on the load, as per the A, B, C sequence settings. The wire gauge and length for each inverter's connection to the AC load should be the same. Solar panel connection. Each device should be individually connected to solar panels. The total output power, wire gauge, and length of the solar panels for each device should be equal. Three-phase grid power connection. Connect three-phase grid power to each device, observing the following. Connect the grid power's neutral wire to the bus bar first. Then, from the bus bar, connect it independently to the grid power input side of each device. The live wire should be connected separately in an A, B, C phase manner, ensuring that the grid power A, B, C phase aligns with the device's configured A, B, C phase. The wire gauge and length for the grid power input connection lines to each inverter should be uniform. Parallel communication system installation. Install the parallel communication resistor with a male connector on the device A. Use parallel communication lines to connect the device A, device B, and device C in sequence. Install the female connector with a parallel communication resistor on the device C. To avoid communication interference, please ensure that the parallel communication lines do not overlap with other wires. Important note, for the selection of wire gauge for all the above connections, refer to the guidelines provided in the user manual. As we move on to the practical aspect of wiring, please heed the following warnings. Wiring steps. Connect the ground wire to establish a safe electrical system. Connect the battery bank to provide power storage. Connect the load to distribute power. Connect the solar panels to harness solar energy. Connect to grid power to integrate with the main electricity supply. Once the input and output wiring for the devices is completed, remember that the system cannot yet output three-phase power. This is because the three devices are not yet communicating in parallel. To resolve this, install parallel communication lines and communication resistors in the devices. The parallel communication line, featuring one male and one female end, connects two charging inverter devices. Attach the male end to the device's female interface and the female end to the device's male interface. A pair of parallel communication resistors consists of one male and one female resistor. Install the male resistor in the device's female interface and the female resistor in the male interface. Remember that these items are non-standard accessories and must be purchased in advance for three-phase applications. For the demonstrated three-phase system, which involves connecting three devices in parallel, prepare two parallel communication lines and a pair of communication resistors beforehand. This illustration shows how to install parallel communication for this three-phase system. The steps for installing the parallel communication system are as follows. Install male communication resistor. Attach the male communication resistor to the female interface of device A. Connect devices A and B. Use the first parallel communication line to link device A with device B. Connect devices B and C. Utilize the second parallel communication line to connect device B with device C. Install female communication resistor. Fit the female communication resistor onto the male interface of device C. To avoid interference, ensure that the parallel communication lines do not cross with other lines, such as PV, battery, or grid power connections. For setups involving more than 3 devices in parallel, like 5 devices, just use additional parallel communication lines to connect them in sequence. Actual installation of communication lines. Install the male communication resistor on device A. Connect device A and B using the first parallel communication line. Link device B and C with the second parallel communication line. Install the female communication resistor on device C. With the completion of the parallel communication installation, your three-phase device setup is ready. Before turning on the devices, double-check that all wiring is correct and secure. Once you've verified this, turn on the devices. You should see A, M, 1, B, S, 1, C, S, 1 on the displays, indicating the phase A, B, C of the output live wire, with M for the master device and S for slave devices. The number 1 signifies one device is online for each phase, matching the initial phase settings. The three-phase device grouping is now successfully installed and ready for use in residential or industrial applications. Remember, safety and precision are key, so always refer to the user manual for specific guidelines. If you have any questions or need further assistance, contact our support team.